LT3598 6-string LED driver from Linear Technology. Welcome to the training module on Linear Technology LT3598 LED driver. The intent of this training module is to provide an overview of the LT3598 LED driver and discuss its key features and applications. The LT3598 is a 45-volt, 2.5 MHz DC-to-DC boost mode converter designed to operate as a constant current LED driver for up to 60 white LEDs. The LT3598 can drive up to 6 strings of LEDs, each with up to 10 30 milliamp white LEDs in series while delivering efficiencies up to 90%. Its input voltage range is 3 volts to 30 volts. It offers 1.5% LED current matching to ensure uniform brightness of the display. Dimming ratios as high as 3,000 to 1 can be obtained by using true color PWM dimming. A programmable 200 kHz to 2.5 MHz fixed frequency operation and current mode architecture offers stable operation over a wide range of supply and output voltages while minimizing the size of the external components. Additionally, the switching frequency is synchronizable to an external clock. Its thermally enhanced 4mm by 4mm QFN package offers a very compact solution footprint for LED backlighting applications. Its multi-channel capability makes it ideal for medium-sized, thin-film transistor LCD backlight applications. Its input voltage range of 3 volts to 30 volts makes it ideal for automotive and industrial applications. The LT3598 uses a constant frequency, peak current mode control scheme to provide excellent line and load regulation. Each string can drive up to 30 milliamps with 1.5% matching accuracy between the strings. The LT3598 has a built-in boost converter which converts the input voltage to a higher output voltage to drive the LEDs. The LED strings are connected to current sources where the current level is set with an external resistor on the I-set pin. The basic loop uses a pulse from an internal oscillator to set the SR latch and turn on the internal power NPN switch Q1. The signal at the non-inverting input of the PWM comparator, the A2 slope, is proportional to the sum of the switch current and oscillator ramp. When slope exceeds Vc, the output of the GM amplifier, the PWM comparator resets the latch. The switch is then turned off, causing the inductor current to lift the SW pin and turn on an external Schottky diode connected to the output. Inductor current flows via the Schottky diode, charging the output capacitor. The switch is turned on again, and the next reset cycle of the internal oscillator. During normal operation, the Vc voltage controls the peak switch current limit and, hence, the inductor current available to the output LEDs. Maximum LED current is programmed by placing a resistor between the I-set pin and ground, or I-set. The I-set pin resistor can be selected from 10K to 100K ohm. The LED current is programmed according to the equation shown. LED current can also be adjusted by programming the control pin voltage. Two different types of dimming control can be used with the LT3598. The LED current can be set by modulating the control pin or the PWM pin. For some applications, a variable DC voltage that adjusts the LED current is the preferred method of brightness control. The control pin voltage can be modulated to set the dimming of the LED string. As the voltage on the control pin increases from 0 volts to 1 volt, the LED current increases from 0 to the programmed LED current level. As the control pin voltage increases beyond 1 volt, it has no effect on the LED current. The LT3598 allows the output LEDs to be programmed for maximum allowable current while still protecting the LEDs from excessive currents at high temperature. This is achieved by programming a voltage at the control pin with a negative temperature coefficient using a resistor divider with temperature-dependent resistance. For true color PWM TM timing, the LT3598 provides up to 3000 to 1 PWM dimming range. This is achieved by allowing the duty cycle of the PWM pin, which is connected to the IC and an internal switch in series with the LEDs, to be reduced from 100% to as low as 0.1% for a PWM frequency of 100 Hz. PWM duty cycle dimming allows for constant LED current to be maintained over the entire dimming range. When the PWM pin is low, switching is disabled and the error amplifier is turned off so that it does not drive the VC pin. Also, all internal nodes on the VC pin are disabled so that the state of the VC pin is maintained on the external compensation capacitor. This feature reduces transient recovery time. When the PWM input again transitions high, the peak switch current returns to the correct value. The LT3598 uses the FB pin to provide regulated overvoltage protection when all LED strings are open. A resistor divider is connected between the VO-SW pin and the ground as shown above. There is an internal PMOS switch between Vout and VO-SW, which is controlled by the PWM signal. The output voltage should be set higher than the normal LED string operating voltage. Under normal operation, LED 1 to LED 6 pin voltages are monitored to provide feedback information to the converter for the output voltage regulation given the programmed LED current. The maximum output regulation loop is activated only when all LEDs are open. The operation of the thermal loop is simple. As the ambient temperature increases, so does the internal junction temperature of the part. Once the programmed maximum junction temperature is reached, the LT3598 begins to linearly reduce the LED current as needed to try and maintain this temperature. This can only be achieved when the ambient temperature stays below the desired maximum junction temperature. If the ambient temperature continues to rise past the programmed maximum junction temperature, the LED's current will be reduced to approximately 5% of the full LED current. While this feature is intended to directly protect the LT3598, it can also be used to derate the LED current at high temperatures. Since there is a direct relationship between the LED temperature and the LT3598 junction temperature, the T-set function also provides some LED current derating at high temperatures. The normal operating frequency of the LT3598 is programmed using a resistor from the RT pin to ground and can be controlled over a 200 kHz to 2.5 MHz range. In addition, the internal oscillator can be synchronized to an external clock applied to the sync pin. RT pin should not be left open. Selecting the optimum switching frequency starts on several factors. Inductor size is reduced with higher frequency, but efficiency drops slightly due to higher switching losses. In addition, some applications require very high duty cycles to drive a large number of LEDs from a low supply. Low switching frequency allows a greater operating duty cycle and hence a greater number of LEDs to be driven. This diagram describes about the typical application on driving 60 white LEDs. The LT3598 are used to drive up to 6 strings of LEDs, each with up to 10 white LEDs in series while delivering efficiencies up to 90%. Designers must select suitable external passive components to work well with the LT3598. However, there are many manufacturers and devices that can be used. Here lists some considerations for your reference. If higher LED current are applied, multiple strings can be combined, enabling the LT3598 to drive up to 2 strings of 10 90 milliamp LEDs. This diagram describes the application for an auto battery powered driver for 20 LEDs.